Hey guys, it is, hold on, widen my screen. It is April 9th, and this is chemistry for April 9th, and we're going to finish up chapter 14, and then chapter 14 was a relatively short chapter. You only have one quiz question on it, so we're going to finish it, and then I'm just going to go over your quiz questions where just as we were highlighting in the book, just to make certain that you've got them all. So where we stopped for Wednesday's lesson was on over on page 238. So now we're going to go over and look at questions, or we're going to pressure changes, and we'll look at some of the questions that you have on your quiz for pressure changes. So since solids and liquids are very difficult to compress, pressure changes have little effect on their concentrations. However, concentrations of gases are greatly affected by changes in pressure due to volume changes. And you can see that by the diagram they give you in your book, what looks really, the differences between those. In effect, pressure changes due to volume changes or changes in the concentration of the gases involved. And this is where, when you get to right here at the bottom where it says equilibrium conditions, or equilibrium systems, I want you to start highlighting, because this next paragraph all the way through the italicized part is a quiz question, and it's one of those things where you have to understand this whole process in order to apply it to something, to a question in your quiz. So let's look at it. Equilibrium systems are affected by such pressure changes only if the total number of moles of gaseous reactants is different from the total number of moles of gaseous products. In such cases, increases in pressure will cause the equilibrium to shift in the direction that produces the smaller number of total moles of gas. And on your quiz, they will actually give you a chemical equation. And in that chemical equation, you know that there's, it will always gives you G or an L or an AQ to tell you if it's gaseous or if it's liquid or if it's aqueous and different things like that, or if it's S, it's a solid. Well, they give you a chemical equation, they list what state the matter is in, and then you have to judge what happens when the pressure increases it. How does it affect the equilibrium? So you might want to read that whole little paragraph. It's not just a term question. This is an application question. And you figure out which way, what's the effect on the equilibrium? Does it shift to the right? Does it shift to the left? Is there no effect? Is it the reaction completed? That type thing. There's also one more quiz question on this page. And it is as you go down into the next section. In this way, the stress of increased pressure can be relieved, and a decrease in pressure on a system at equilibrium will cause a shift in the direction that produces the larger number of total moles of gas. Then, right before you get to that example, 14.2, that next little section is a quiz question, and you need to go ahead and highlight that. If the number of moles of gaseous products equals the number of moles of gaseous reactants, pressure changes have no effect on an equilibrium system. Just going to glance at this next question. So basically, this is another one where it's an application question. It's not a term question. They will give you a chemical equation, and you have to look at it. All of them on both sides are gaseous. So you go from gas to another type of gas, and think about what that's telling you. If the number of moles of gaseous products equals the number of moles of gaseous reactants, then pressure changes have no effect on an equilibrium system. And then you have to say, once again, what is the effect on this? There's at least, guys, 4 questions that's what it's asking you, is what's the effect of this? They show you a chemical equation, and then you have to judge from that chemical equation what's happening to the equilibrium. Is it shifting to products? Is it shifting to reactants? Is it shifting to, is there no shift? Or is there potentially the reaction goes through a completion process? So we have 2 more that's kind of like that. If we look over under temperature changes, All chemical reactions involve energy changes, either through a liberation or an absorption of energy. Most often, this appears as heat. Reactions that liberate heat, and we've had this several chapters ago, like the dynamic chapter, I think is what it's called, thermodynamics. Anyway, reactions that liberate heat are exothermic reactions, and those that absorb heat are considered endothermic reactions. A reversible reaction that is endothermic in one direction must be exothermic in the other reaction. And you can more easily understand the effects of temperature changes on an equilibrium system by including the word heat in the equation. So if you, that's why for a few of these, they're just trying to figure, you put in the word heat. Of course, the other way they would show that is with the little delta over the arrow signs that shows that as well. So where I want to go over to your next question, you can read about temperature changes because they'll give you several examples for there. But the next question you've got coming up is under effects of a catalyst. Okay, so effects of a catalyst. Did I have one there? I did have that one. Hold on, I'm just checking myself to make sure that we've got two there. We had that one, was over here on page 238. You have one more quiz question, and that quiz question is on page 240, and it's talking about the effect of a catalyst. So let's look over here under the effects of a catalyst on page 240. A catalyst alters the rates of both the forward and reverse reactions equally by lowering the activation energy. Therefore, a catalyst has no effect on the final concentrations reached at equilibrium. So you need to go kind of highlight that so you can actually remember this for a quiz question. A catalyst has no effect on the final concentrations reached at an equilibrium. You have to know that italicized part for a quiz question. It's the way that and you might want to highlight the next sentence as well because it's just saying something similar with the same effect. A catalyst may increase the rate at which a reaction reaches equilibrium, but it has no effect on equilibrium concentration. So you have to be able to know that and be able to apply it in a multiple choice form there on that. The rest we'll go over the Haber process just a bit because that's what the next section is the Haber process on page 241. And this one is showing this pump and some different things on it. To be honest, the rest of your chapter of 14, there's not any quiz questions from that section, and it involves basically a lot of processing. If you were taking the test over it, you would have to know being able to do some of these equilibrium constants. But since this is kind of a short and wild year, I'm not going to go over that because you all probably have a difficult time. I mean, I know my own children, they have started, since they're not going to school, they're also trying to work. You might be trying to do the same thing. So I'm not going to go over that section. You can read that if you wish. What I am going to do is just go all the way back to 14, and I'm just going to go over your quiz questions just to make sure you've got them all. Hold on, I have something on my glasses and it keeps bothering me. What is that? Oh well, it's gone. So let's go to chapter 14. So your first quiz question was over reversible reactions, and I told you to basically highlight the definition that comes after the bold word on page 235 for reversible reactions. Your next quiz question was over chemical equilibrium. That's on page 236, and that is also a pretty much a term question. I ask you to highlight everything right before equilibrium, chemical equilibrium, because that was the definition. It came before it, not after it. So that's two test questions. On page 237, you have two questions there, but I kind of, told you some clarifications for that one because they ask it in a little bit odd of a way. One is simply the Le Chatelier's, knowing that principle. So that is, if a stress is applied to a system at equilibrium, then the system will react in such a way that the stress is at least partially offset. But instead of saying partially offset, I want to say on your quiz, they actually use the words minimizes the effect of the stress. So they ask it a little bit differently. Make sure that doesn't confuse you. Another test question that comes from page 237, but it just doesn't come right out, is you have to know that relative concentrations depend on the reaction. They ask you a question about relative concentrations, and you have to know that that depends on the reaction. That's a multiple choice question. Just remember, relative concentrations depend on the reaction. Turning the next page, on page 238, you have a question from 238. It was right under, it's the second column, right under the chemical equation 14.7. If a product is continually removed as it forms, the reaction toward the left has little chance of occurring, and the forward reaction is driven to completion. And I am going to look down. So that one, once again, it talks to you about going to completion. So it's a reaction that goes to completion. There's a question about a reaction and how it goes all the way through to completion. If we move to page 239, this was 2 application type questions that, it's not a term question, it's an application question. So equilibrium systems are affected by such pressure changes only if the total number of moles of gaseous reactants is different from the total number of moles of gaseous products, in such cases, increases in pressure will cause the equilibrium to shift in the direction that produces the smaller number of total moles of gas. That they give you a chemical equation, and you have to judge by the chemical equation what is happening, if it's shifting to the right, to the left, if there's no effect on the equilibrium, or if it's going through completion. The other application question you have to know is down there underneath this question, right above example 14.2. If the number of moles of gaseous products equals the number of moles of gaseous reactants, pressure changes have no effect on an equilibrium system. Once again, that's one of those application questions, and actually they don't give you a chemical equation with that one, but they just ask you what's the effects, and you have to be able to put that down. Hopefully remember your quizzes are open book until such time this is over. So then your last question that we have gone over is on page 240, and on 240 it's about the effects of a catalyst. A catalyst has no effect on the final concentrations reached at equilibrium. So a catalyst may increase the rate at which a reaction reaches equilibrium, but it has no effect on equilibrium concentrations. So that's the effect of a catalyst on concentrations, that there's no effect of that. That's another quiz question. So this completes chapter 14. So you have this week coming to you. This is like on, what day did I say this was on? This is on April 9th, today's video. And you should be working on quizzes, working on a test. So I'm not doing a new video until April 13th. And that's when we start acids and bases and all those on chapter 15 on April 13th. So have a good week. Stay well. Get some sunshine. And remember, I love you, and we'll close in prayer. So Heavenly Father, thank you for gathering us again on this beautiful day. And I just pray that you'll just be with everyone, guide them, clear their minds, and help them concentrate on their schoolwork as well as work and all the many other things they have to do. We love you. In Jesus' name, amen. Have a good day, guys. See ya.